Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GHEtool Cloud. And in this video we will be talking about simulating hybrid systems. Now if you've been following our YouTube channel or knowledge base for quite some time, you know that we already talked sometimes about hybrid systems and more because it's an increasingly important subject. So what we talked about in the past was basically, first of all, what are hybrid systems? And we said that, well, a hybrid system is just having a combination of technologies to heat and cool your buildings. So having a ground source heat pump with, for example, an air source heat pump. We then talked about methodologies on how you can design your bore field in such a way that you have maximum power, maximum energy extraction. We talked about an example in GHEtool, how you can use our software to simulate and to calculate actually these solutions. Then we added another methodology for optimizing these systems, now taking into account the imbalance. And today we will be talking about a totally new method, a totally new module, basically for simulation. So what's the difference between optimization and simulation? It's a rather subtle difference, but it's an important one. So when we are going for an optimization strategy, what we want to do is we want to find the optimal solution given certain boundary conditions and an objective function. So in GHEtool, this is we maximize for either the power, the energy, or the balance. So practically we have a certain borehole configuration, a certain number of boreholes, a certain depth. We have a load profile, and we will ask the software to calculate or optimize the system for a maximum power. This requires iteration because we want to make sure that the temperature stays within limits. So we simulate, we find out, well, the temperatures are not within the limits, we adapt our load profile and we simulate again, and we adapt and simulate, adapt and simulate. So it requires iteration, and that's why it is slower. And this is implemented in GHEtool as the optimized load profile aim. Now for simulation, the story is a little bit different. So here we're going to simulate the solution, given certain boundary conditions, of a certain control strategy. So here there is no iteration needed. It's just taking into account, okay, we define how our system will behave, basically, and we just simulate it once, and that's why it is way faster, and this is now implemented as a hybrid system module. Now, just to explain this a little bit more clearly, currently the optimized load profile, what it did is we took a fixed bore field size in the load profile, and then we calculate the maximum geothermal share. And we can do this again either for maximum power, energy, or balance. But you as a user, you do not have any influence on when this hybrid system will work, because that's a result from the optimization. And this means that the control strategy on when which system will work is implied. So because we want to stay within certain temperature limits, whenever the fluid crosses it, the algorithm adapts the power in order to make sure that it stays within the limits. So the control strategy is based on the temperature limitations, and it's not explicit. You as a user cannot enter this control strategy. So if you're going to build this system in practice, it's less straightforward to implement a controller for this. So that's why we now added another module to simulate a hybrid system. So here we again start with a fixed bore field size. We also upload a weather file now and a load profile. And what we will do is we will calculate the resulting temperature profile. So this means that we start from a temperature-based control strategy. Now, to illustrate this, just an example, imagine you have a large collective system, perhaps 5th generation district heating, which has both a ground source and an air source heat. Now, we typically know that when the outside temperature is above a certain threshold, typically 10 to 12 degrees Celsius, that our air source heat pump will have a better efficiency than our ground source heat pump, due to the fact that our source temperature is different. Now, if our outside temperature is above this threshold, it can be beneficial to use an air source heat pump instead of a ground source heat pump. And that's exactly what you now can simulate. So what you do is you enter the power of the air source heat pump, you enter the threshold, the system will calculate, okay, based on a weather file, we know that at this times the air source heat pump will be the preferred way of simulate or heating the building, and the other load is put onto the bore field. Now, that's one example. There are more, but important to know is that it's not necessarily the optimal solution you find. It's not an optimization. You're entering criteria and control strategies yourself, but it's really easy to play around with certain settings, certain thresholds, and see how your system should be adapted to cope with this type of control strategy. So we already talked about this example, but for example, also renovation context. Imagine you have a school building which is not that well insulated, but you want to install a ground source heat pump there. We have high temperature emission systems with an existing gas boiler, but these emission systems can also work with our ground source heat pump. But when it's too cold outside due to the poor insulation, our ground source heat pump cannot heat our building efficiency. For example, when it's below 2 degrees outside. So what we then can say is, well, if our temperature is outside below this threshold, then our gas boiler again turns on. So we simulate a hybrid system in this way. Or perhaps if we are looking at an office building with a high cooling peak, when it's too hot outside, it can be that the air handling unit cannot cool the air sufficiently with passive temperatures, and that our battery that we should install, the heat exchanger that we should install in our air handling unit is just too big. It cannot cope with these passive temperatures. So what we can do is we can opt for active and passive cooling in the combination. That's another story, we discussed about that before. Or we can go for a hybridization where we say, well, if the temperature is, for example, above 22 degrees outside, then our hybrid system turns on and it will start cooling actively. So these are just a couple of examples. I suggest we jump into GHEtool and I show you how you can use this module for your own project. So here we are in GHEtool. I created a new project, and as you can see on the right, we have this new option to add a hybrid system. Now it's disabled for the moment because you need to have an hourly load profile in order to use it. Just go over our project real quick. We have certain ground parameters, the default ones. We have a rather big bore field of 160 boreholes with 150 meters of borehole length. We have a borehole resistance, a DN32 with 0.3 liters of monopropylene glycol. And for our thermal demand, we're going to upload a CSV file with our demands data. Now, let me go ahead and do that. So let's import the load profile, and I will simulate it so you see how the baseline scenario works. Now, if we go ahead and go back to the general tab, we see that we have now this option to add a hybrid system. Now, this is basically the result now. So if we have an hourly temperature profile with certain limitations, maximum and minimum average fluid temperature. By the way, we also added a new graph here to also visualize the hourly load profile you imported, so you can zoom in on that as well to make life a little bit more easy. And let me go ahead and duplicate this scenario. And let's call this hybrid to make it easy. On the general tab, we will select now add a hybrid system, and this will open up a new section. Now, you always need to upload an EPW weather file, because as we discussed, this hybrid method, it works with, or this hybrid simulation works with reference to the outside temperature. So you need a weather file. Normally you use the same weather file as was used to create the hourly profile. In case you're interested, you have this climate website, climate1building.org, where you have for all the regions in the world, all the different countries, all the different locations on all three weather files. So we will link also to that in the description. You can find quite a lot of it for free there. We already uploaded it. And then we have 4 options for our hybrid systems. Now, it's not by definition that this means that we have 4 different hybrid systems. It's just that we have 4 different, how should I put it, use cases. So we have here our hybrid system, which works when we are above a certain threshold. So this is, for example, the case as we discussed where we have a ground source and an air source heat pump above a certain threshold. The SOS heat pump will jump on. I already filled in this case. Recall the simulation for the school. So where we say above a certain threshold, we have a certain hybrid technology that will jump on, that will turn on to work together with our ground source heat pump. And we have the same for cooling. So our hybrid cooling above a threshold when, for example, the air handling unit cannot cope with the high peak demand, and vice versa, also below a certain threshold. I will come back to this set maximum power for the bore field in a second. So let us now go ahead and simulate this and show you how easy it is to obtain different results or different insights in your system. So this is the result we end up with. You see again an hourly temperature profile, but now we have more. We have here our monthly energy balance, where you see that geothermal heating in January is of course the biggest part, but we have here a hybrid heating below the threshold of, in this case, exactly 10 megawatt hours. In February as well, but in April also. There are apparently in my weather file still some temperatures below 2 degrees in April. And you see here that the energy share for your hybrid system below the threshold is around a little bit short of 4%. This means that our yearly imbalance is slightly different when compared to the first scenario, which is really interesting to see. You have here also the option to really download the hourly profile. So if you simulate for hybrid systems, you can export the hourly profile so you can check when the heat pump turns on or off. Now let's perhaps make another example. Let's say that if we are above 10 degrees, that the 200 kilowatts air source heat pump will kick in. It's just to show you a little bit how these things work. And now you can see that the imbalance is still somewhat lower, since now we have also a hybrid heating above thresholds. So here we see that now we have our geothermal system working for around 97% of the time, 4% a hybrid system below the threshold, and 70% our hybrid system above a certain threshold. You also see that here clearly on the Sankey diagram, where the share of hybrid system heating is now increased. So this is basically how you do it. You can also do it with cooling. Perhaps I will also show you that real quick. So when it's above, let's say 20 degrees, we have 100 kilowatt as well. The same 100 kilowatt as here can be used, for example, also for cooling. Let's simulate also that real quick. So here we again see the same thing, where in summer now we have in August a certain amount of cooling, and also for our hybrid cooling system. And you see here now the two circle parts for the geothermal part and the hybrid cooling above our thresholds. Now there was still a button I didn't use, and it's a set the maximum power for the bore field. Now, instead of saying, well, we add a certain geothermal share or a certain hybrid solution, what we can, for example, say is that let's go ahead and set this all to 0 for a moment and set the cooling to 1000 so we don't have to worry about it. Our building, if you recall, from a previous example was 530 kilowatts of heating. Now imagine we only install 475 kilowatts. If we simulate this, it will take this 475 into account, and everything that requires a higher power is now noted as excess energy because it's not delivered by the system itself. So you can see if instead of having this 536 kilowatts, if we only install 475, that we have a little bit of excess heating, so 1.2% of our heating demand cannot be fulfilled. So this can also be an interesting feature just to play a little bit around with how big should your heat pump really be, and if it's smaller, what hybrid system can work together with it. So this was everything I wanted to say about this new simulation module. I hope I showed you that it's really quick to use. It's really powerful. You can really play with quite a lot of things. You can also combine it with the calculate required depth option, because this does not require any iteration. You can take this hybrid system into account to calculate your required borehole depth. You can for sure try that out if you want. I should mention that this is not yet included in the report. We will update the report later this month, and we will take these changes as well as the hydraulic simulation into account for the new report version. So stay tuned for that, and I hope I can see you in the next video. Take care. Bye.